we're starting class officially. Bing! All right, so our goal. We're going to try to learn and review the 3 states of matter, okay, because we're starting chemistry. Chemistry starts. All right, welcome to Cooking with Chemistry and Miss Curry. All right, and then we're going to review our, and then we also want to learn a new word called sublimation. Y'all in the classroom, y'all notice it says 3 states of matter is in red, and this is squared off and marked sublimation. To sublimate, okay? So we're going to learn that word and see it in action. And this is going to launch our chemistry unit. Everybody with me? Table right here. Okay, I'm going to point this down. And everybody at home, we're going to be doing experiments with dry ice. So everybody, what exactly is dry ice? That's what I want to know. Yes. It's very cold ice, very cold. That's true. I can't even really touch it with my fingers without hurting my skin a little. Yes? Its boiling point is room temperature. That means a boiling point means it's going from into what state of matter? When it boils gas, it's going into a gas at our room temperature, and that's exactly right. At our room temperature, it's turning to a gas, okay? Now, anybody at home, if you, Tommy, go ahead, talk.
I was gonna say it's like made out of carbon dioxide and stuff.
Thank you very much. It is. It's not frozen H2O. It's not frozen water. It's frozen carbon dioxide, CO2. Yes? You get carbon dioxide, you put it, you pressurize it and put it in, you freeze it. You bring it below its freezing point. Now, this is not an element. An element is pure. An element is like pure gold, pure silver, pure oxygen, pure carbon. It's made out of only itself, those atoms, okay? But this is a molecule. Does that help you see? This is a molecule and it's CO2. Dry ice. All right. So dry ice is frozen CO2, all right, frozen CO2, and it is carbon dioxide, and it does something unusual compared to H2O. Y'all can pull up chairs because we're going to be here for a while. So H2O, when it gets warm and it's frozen H2O, we call that ice. And normal frozen H2O, when it gets warm, what do we say it happens to it? It melts, we say, and she said it turns into water. Well, it's always water. It turns into a liquid state. There are 3 states of matter. Really, there's 4. One is plasma, but that's only, we'll talk about that later. But on Earth, we have 3 normal, in our atmosphere, have 3 normal states of matter. Solid, liquid, gas. Solid, liquid, gas, 3 states of matter. And so this is carbon dioxide, not water. So do you see any drips anywhere? No drips. None. That's frozen, that's liquid. They see some liquid, but that's liquid from this room of water vapor in this room. Okay, that was freezing and making something cold, but from the actual, it's never gonna drip. I could sit here and hold it and we could just sit there and watch it. It's never gonna drip water, liquid CO2, I should say. So if you had to guess, what would sublimation mean? To sublimate. Yes? It's not frozen forever because eventually this will go away. What's happening to it? What's happening to it? Say out loud, what's happening to it?
Not dripping.
What's it turning into? What state of matter is turning into a gas? That's what some people were saying. It's going straight from a solid to a gas form. It is not, it's skipping. It's just skipping the liquid form. That's called sublimation. There are some air fresheners that if you let them, you lift it up and you let that gel sit there, the smell diffuses through the room, but it never really gets drippy and gross. It just slowly disappears. That gel disappears. It's sublimating. It goes from solid straight to a gas form. So what do you think is making it make that sound? What was vibrating? What was making it make that sound? What was making it make that sound, everybody? It wasn't heat. It was no, it wasn't water. It's carbon dioxide turning into a gas, and it was touching that table, and it didn't have space. And so it was making the table vibrate as that carbon dioxide hit this. But right now, it's like sliding all over the place. So what makes it like an air hockey game? What if you do air hockey? What?
It's frictionless.
Yeah, but why? What's between the frozen carbon dioxide and the table?
The gas.
Gas. What gas?
Carbon dioxide.
So it's sublimating, and it's floating on its own little, I guess, pillow of carbon dioxide. Okay. Then, and this is all chemistry. Chemistry explains everything in the universe. So now I'm going to take this. I'm going to put it in water. That's an H2O.
Oh, it's gonna make it carbonated.
Way, yeah, that's what we put in carbonated drinks. And
I've done that.
look at that. And this, but wait, turn your voices off. So why did the ice turn transparent? Let's see if it's transparent. That's the water molecules bubbling around it, but the actual carbon dioxide is not. You're just seeing water going around it. The sublimation point is negative 78.5 degrees Celsius. So at room temperature, to sum it up, at room temperature, it's going from a solid straight to a gas, just like Alara said. Now, what's making the fog? I'm on the next explanation. So it says, well, if you put this, let's say, in at Halloween, you put it in like a thing of punch. You have to be sure that the dry ice never is in a position where it could be scooped up, and even a little bit going down your throat would freeze those tissues down your esophagus, and you would be harmed because your body is not made for these cold temperatures. So instead, you would have this in like it would be where if I dipped the punch, I can't go in here. You would make it where you can't go, like maybe a screen over it, so the fog's coming out of the punch, but no one's able to get to it. Okay, just so you know, just as a precaution. Yes. It would start, yeah, damaging your esophagus. Yes, you could. Yeah, it would damage your yes, it would. I'm telling you, if the carbon dioxide in a frozen state goes into your mouth, your tongue will be damaged, your esophagus tissues will be damaged. Don't do it. Okay.
I saw Miss Curry. I saw a video on if you ate some of that, and basically if you eat enough, and like if you drink liquid nitrogen or something like that, your entire inner lungs and throat would freeze.
Yeah, mostly, and liquid nitrogen is even colder than this. Absolutely. 2 questions on the floor. Go ahead. Publix. You can go to the grocery store. They have a special freezer for it, but you have to be 18 or above to buy it. So let's talk about looking at this. This cloud is a cloud. That is actually, I'm touching a cloud. I'm touching, in this room is water vapor. In this is water vapor, okay? And you're seeing like in this room, there's water hitting your face. It's in a gas form. When it gets cool, it's going to be turning into a cloud. It's condensing. And so we're not really seeing a cloud of carbon dioxide. The carbon dioxide is going through that cloud and into the room. So this carbon dioxide is always sublimating. It goes into the water. And as it says, you're actually observing tiny droplets of liquid water that have been dragged up with those bubbles of sublimation of carbon dioxide, and it dragged up. but it's cooling and turns into a cloud. Notice when it's coming up, it has carbon dioxide and H2O in it, and you'll notice it's going down. It's because that's making it more dense. It has more matter in it than the air surrounding it. So it goes downward. So now we just have cold water here because there is no dry ice in it. And that dry ice chunk sublimated. Okay, we're gonna call this the squeaking coin. All right. So if I take this, oh, it's doing it for me. So we got to figure out, why is it making that noise? Why is it squeaking? I could also take my mitten and I could hold it. Or I could take this ice cream scoop and I could hold it on that. Oh, excuse me. Oh my goodness. That was the dry ice, not me. I know. I'm so funny. I know. Okay, so right here. Is the dry ice making any noise?
No.
But was the metal making noise?
Yes.
It's not making noise now.
No.
So what's happening? Okay, the carbon dioxide is making noise when it touches the metal. It has nowhere to go. So right now, this carbon dioxide is sublimating this way, that way, that way, that way, that way, onto my mitten, but it's soft, so it can kind of go through that cloth. But here is a solid object that it can't go through. And I'm gonna not just put it on there, but I'm gonna push it on there to trap, so that any sublimation that's happening in that surface is going to hit this metal. And it's going up against the metal and scooting out. So I could take any kind of metal object, even the slotted spoon. No, I'm like, I could take over the music world, I know. All right, so that is the squeaking coin, and it proves that the gas, the solid is going to a gas form, straight to a gas form, and with some air, with some pressure, it's hitting my hand, it's hitting this, it's hitting all the molecules in the air, it's going upward, it's going everywhere, all the time into a gas form. Okay, now, freezing flower petals. Looks like clear liquid to everyone. It looks, you'd assume it's water if you're just looking at the camera, but in reality, it is acetone, A-C-E-T-O-N-E, acetone. So this is a lily, okay, and one type of lily, and stargazer. And I'm taking this beautiful flower, and I'm going to do something to make it not flexible. If you look, it's really flexible. So I can bend it and it doesn't break, right? Right? So now, with the acetone, I'm going to take the great big piece of dry ice, and I'm going to safely put it in there, okay? This is a safety issue, so I need everybody to stay seated, okay? And I'll let you kind of pop up to look in general, but it'll be dramatic. Everybody at home, you should be able to see it. I hope this is a big enough piece. And put the flour into the acetone. It looks like the acetone is actually boiling, but it's not boiling. It's not boiling, it's bubbling, it's sublimating. But this is a different freezing point. So that acetone is getting incredibly cold now. It's colder than water would be with the dry ice in it, okay? And the dry ice is getting pretty small, so I'm gonna go ahead and start. Okay, take a look. It's crunchy. It just broke. It's crunchy. Yeah, it sounds like
That is so satisfying.
It is so satisfying. It is. You just want to crunch things, you know?
Exactly.
Yeah. Now, I have a slice of apple. I don't know if it's to be cold enough, but since we have a big piece, I don't always do this, but I'm going to put a slice of apple in there. We'll see if we can freeze that apple. Again, in water, it wouldn't happen so well,
Now, if you have frozen nitrogen, which you would not have unless you were in a chemistry lab, it's much more dangerous. Frozen nitrogen would totally freeze a tennis ball, and I could throw a tennis ball on the floor and it would be so frozen it would shatter into little pieces like powder. Yes. It's pretty solid. That was an apple slice.
It looks like styrofoam.
Yeah, yeah. So it's totally just, it's frozen. It froze that fast. But wait, there's more. Okay, here we go. I'm now going to take, let's scoot our studio audience over for our view of the sink. Except my roller doesn't roll very well. Okay, hang on. It's exciting. I know. Ooh, our live audience is very excited about our root beer. That's right, root beer from Harris Teeter. Shop there. They're your friend. Okay, maybe they'll pay me. All right, everybody, we're going to uncap our root beer. If you remember, root beer is a carbonated drink. If it's a carbonated drink, what does that mean? Yeah. It bubbles. Why does it bubble? It has carbon dioxide in it, but it's not frozen. It's carbon dioxide in a gas form. And then it's pressurized because they sealed it up. And when they did that, the carbon dioxide couldn't get out. And when you undo it, the cap, the fizzy comes out because some of that carbon dioxide is immediately going into the air of the room, right? All right. Now we're going to take and we're going to lodge some dry ice in there, and we're going to see what happens. For our studio audience at home, sometimes this is incredibly dramatic, and sometimes it's like, oh, that's nice, Miss Curry. So we're just going to go with it, okay? Because how often do you have a class put dry ice into a bottle of root beer? Yes. Oh, we want a soda fountain. A soda fountain. Here we go. I'm hoping I can get both in there, but I don't know.
Push it down in there.
I'm going to. I'm trying. I think I'm gonna have to go with one. Yeah, I gotta get my official hammer. You ready?
Yeah.
Now, no matter what, be a good studio audience. Ready?
Yeah.
Woo! That's so nice. Now, what you see right now is the same cloud you saw when it was in water. And that is actually a cloud of water. Why is that a cloud of water? Where's the water coming from? The root beer, because what is the liquid of the root beer? Water. So it's still sublimating inside the bottle, but it's making the water also kind of get caught up and become cool and become a cloud. All right, sublimate. Going from a solid, skipping the liquid. When it gets warm, it goes straight from a solid to a gas, sublimation. Everybody on your tomorrow, if you look at the very last of our module pieces today, there's a discussion. We will start tomorrow with a discussion and you have to explain sublimation. I hope you had fun. Hope you enjoyed chemistry.